Hi everyone, and welcome to video 1.3. So in this video we're going to learn a couple formulas and what midpoint means, and we're going to look at that on a graph as well. Okay, so let's get started with the vocabulary. So we talked about segments and congruent segments and all that and what that means. So when we talk about the midpoint, that's the point that divides a segment into two congruent segments. So it's just a point that's exactly in the middle of the endpoints. And that can only be for a segment because we can't divide a line because the line goes on forever. Okay, so a segment bisector. So if we're not saying that it's a midpoint, specifically a point, a segment bisector can be anything that divides the segment into two equal parts. So a point, line, segment, or a plane. The bisector, if it's going to be a line, it always has the midpoint on it. So the midpoint's there, it just doesn't have to be a point only, it could be a line. So like in this picture, we could have drawn a line that goes through it, and then point E is the midpoint, but that line would be the segment bisector. Okay, so that midpoint always creates two congruent segments, and I just wrote out, so DE is congruent to EF. Because E is the midpoint, because remember we talked about what these little things mean, those are congruency marks. Okay, so that's how we kind of look at it if it's a picture of a segment like that. We can also be given some ordered pairs, 2 points, and find the midpoint with the ordered pairs. So this is kind of looking at it more graphically. So to find the point, we just add the corresponding coordinates and divide them by 2, because we're finding exactly what's in the middle, which is what you would do if you were finding the middle of two numbers. Like if we wanted to find the middle of 2 and 18, we would say, okay, 2 plus 18 is 20, so what's exactly in the middle, split it in half, is 10. So that's exactly what we're doing here. We're adding them together and dividing by 2. Okay, so we'll practice that in a second. So we have one other formula, and that's the distance formula. Okay, and the distance formula is this long, complicated thing, but it tells us how far are 2 points on a graph. Okay, so if we have 2 points, then this will say, okay, those points are exactly this far apart. And if our segments, or the points that are formed, or the segment that's formed with those 2 points is horizontal or vertical, like it was when we talked about stuff in section 1.2, then we can just count how big they are. Like, you remember these? So like here, we can count how far apart those are, how many boxes, and that would be the length. So those were 9 apart. But if our line is diagonal, like this, we can't do that because it's at a diagonal. So this is how we would figure out how far apart they are. Okay. So you can use that formula, or you can use this way I'm going to show you right here. And this is kind of a shortcut if you're good with the Pythagorean theorem. It's just a different way, but usually when we talk about distance, points on a graph, we use the distance formula, which I will show you how to use this when we get to those examples. But first, we're going to show that it works by making the Pythagorean theorem, or not making the Pythagorean theorem, but using the Pythagorean theorem. So first, to use the Pythagorean theorem, we need a right triangle. So I'm just going to drop a horizontal line, and then, or a vertical line, and then a horizontal line. So now I have my right triangle. Okay, so we can use the Pythagorean theorem to figure out how big this missing side is. Because again, we can count these sides because they're horizontal and vertical. So the side that's across from angle A would be side A. So this is side A. Across from B would be side B. And then we'll call this one side C. That would be angle C. So there's our A, B, and C for our Pythagorean theorem. So remember, with the Pythagorean theorem, we have A squared plus B squared equals C squared. And so now if we count this side A, 2, 4, 6, we get that this side is 6. So we'd have 6 squared plus B is 2, 4, 6, 8. So that side's 8. And again, we can't count this side because it's slanted. It's not horizontal or vertical. So using the Pythagorean theorem, since we made a right triangle, we can do that. So we have 36 plus 64 equals C squared. And remember, when you get it down to this, we take the square root of both sides. So that means that that side here, this length, is 10. If we would have plugged in the points for A and B into this formula, we would have got 10 there as well. This is just a different maybe more simple way of looking at it. Okay, so if you have your points on your graph, I don't care if you do it this way or use the formula. Both of them are going to get you the same answer. Okay, so let's take a look at our examples for all those little things we just talked about and see if we can get them figured out. So our first question says that the midpoint, M is the midpoint of PQ, and then they tell us what some of those segments are, and we want to find the length by drawing a diagram. Okay, so I'm going to draw a sketch. So we have segment PQ, and then M is the midpoint, so I know that those are exactly equal. So they told us that PM is 7x plus 8, and that MQ is 5x plus 20. So if M is the midpoint, what do we know about these two segments? Very good. They are exactly the same size. So that means that these pieces are equal. So if these pieces are equal, then that means that those are equal. Okay? So if M is the midpoint, then that means PM is equal to MQ, or 7x plus 8 is equal to 5x plus 20. So now we can solve for x. So subtract the 8, subtract the 5x. So 2x equals 12. So we get that x is 6. So it said to find the length of each side, so that means we're going to need to plug them back in. But since they are both the same, we only have to do it to one side. So you can pick which one you'd want to plug it into. So 7 times 6 plus 8. So 42 plus 8 is 50. So that means that PM is equal to MQ, which equals 50. And then we can also say that PQ would be 100. Very good, because 50 and 50 is 100. So then there's all of our segments. Good job. Remember, if you don't understand anything we just talked about, draw a star, circle it, highlight it, something, write it down, so that way you'll remember to ask in class when we go over this. Okay, so for number 2, same idea, except they gave us our picture, so it's a little more straightforward. But since we have that B is the midpoint, we know that the pieces on both sides are going to be congruent. Now you're saying, how do I know that B is the midpoint? Well, we know that because of our magic congruency marks. Those are going to be your best friend. So if the two sides are congruent, they're equal, B is exactly in the middle. So go ahead and set up your equation and solve for x, and then it says to find the length of each segment, so you'll have to plug it back in. So please pause your video and figure out question number 2. Okay, very good. I hope you got 8. Glad you're working so hard. So we got that the two pieces are 29, so the whole segment would be 58. Awesome. Let's go to question number 3. So this one says to find the midpoint. We're given points this time instead of a picture. So it's no equations like what we've set up for here. It's using that formula. So remember, our formula says add the x coordinates together, divide by 2. Add the y coordinates together, divide by 2. And this is your ordered pair. That's the point that's exactly in the middle. See how it has your parentheses and a comma? That means it's a point, your x and y. Okay, so let's set that up. So we're going to add the x coordinates together, x1 plus x2, and divide that answer by 2. And then we'll add the y coordinates together and divide that answer by 2. Okay, so my x coordinates are 1 and 4, so 1 plus 4. My y coordinates -3 and 2. And if it helps you to write like x1, y1, x2, y2, then you should do that. Okay, so whatever helps you figure it out. I know sometimes it's hard to remember what goes where, but this is our first point, so I labeled it with 1s, and this is our second point, so I labeled it with 2s. Really, we could have done the reverse and still got the same answer. So if we add the numerators, we get that, and then you can leave it like that, or you can change them to decimals. Usually, if it's talking about ordered pairs, I make them decimals and not leave them as fractions, but otherwise I always leave everything as fractions. Okay, so sometimes you might see this written with an M out here, because that M stands for midpoint, like, you know, the P and Q here are the names of the points. So we'll put an M here to represent this is the midpoint of that. And if you, I didn't put it on here, but a lot of times the formula would have an M in the front as well. But that's what that M stands for, is just the name of the point, which is our midpoint, so we're using the letter M. Okay, So that's the only example like that. So if you're having problems with that, then make sure you ask in class. Okay, we're going to practice some more next class, but I just want to make sure you guys are set with the midpoint. So let's take a look at question number 4. Well, actually, we're going to skip to 6. 6 and 4 are kind of the same, but it's like backwards. So for number 6, it says that the midpoint of segment HW is at -5, 1, and H is there. When we want to find the coordinate of W this time. So they gave us our midpoint, and now we're looking for an endpoint. So I'm going to draw a segment, a picture, to try to help us. So we know our endpoints are H and W, and then we have our midpoint. Okay, and they told us our coordinates are -5, 1 for our midpoint, and H is at 3, 4. Okay, now we're looking for W. So I want us to take a look at this. Remember that M is the midpoint. It's exactly in the middle. Okay, so if you think about it, that however far I'm going to get to here, I'm going to have to go the same distance to get to that next point, because this is the same as this, because M is in the middle. Okay, so to change from my x coordinate here to my x coordinate here, how much did I move? Very good. I went over -8. So 3, the difference between there is -8. 3 minus -5 minus 3, -8. So that means to go from here to here, I'm also going to have to subtract 8. So -5 minus 8. So that means that W would be at -13. Okay. So if we take a look at the y coordinates, I go from 4 to 1. So what would I do to go from 4 to 1? Very good. We subtracted 3. So that means to go from here to here, I would subtract 3. So this would be 1 minus 3, which gives us -2. And that's it. So that's our point W. Okay. So I want you to pause it and try 4. It's the same thing, except instead of giving you this point and finding this one, they give you this one and you have to find this other side. So try it just like we did. See what change you make from here to here, and then you would do the same thing to get from there to there. Okay? So pause and do number 4. Okay, so here is my work for 4. I kind of did it a little weird. So I said, okay, what am I doing to get to here to here? So from -1 to 4, I added 5. But now from your midpoint, I'm going backwards. So instead of adding 5, I would actually subtract 5. Okay, so same thing for my y's. To get from -2 to 4, I add 6. So I'm going backwards, I subtract 6. So that means our point V is at -6, -8. And I even checked my work. So I said, okay, if these are my endpoints, do I come out with this midpoint? So if I do the midpoint formula, I did get -1, -2. And I did it for number 6 as well. And I got the right midpoint, so we know we were right. We should have checked our work, but we didn't. Okay. Okay, so let's look at question number 5. So it says to find the length of RS. So that's using our distance formula. So our distance formula said x2 minus x1 squared plus y2 minus y1 squared. So remember, this is x1, y1, x2, y2. So we can plug those in. So we have 4 minus 2 squared plus -1 minus 3 squared. And after that, you just need to do the order of operations and simplify your parentheses and stuff. So the first thing we'll do is our parentheses. So this would be 2 squared, which I didn't need to write the parentheses, but sometimes I do anyways. And that's -4. For that one I do because the negative. Okay, so that's 4. Remember, that means 2 times 2. -4 times -4 is 16. So we get the square root of 20. So for these, I'd like you to leave them as simplified radicals, like what we practiced for summer homework, just so we have exact solutions. I know sometimes in applications we might need to change them to decimals, but I like the simplified radicals. I like exact answers. So remember, we make our factor tree and then see if we have any couples. So we have one couple of 2's. So those go to prom, and then our 5 doesn't have a partner, so it stays home. So our answer would be 2 root 5. Okay, very good. Let's try to finish up the back, and then we'll be done. So we have another construction, and this time we're constructing the perpendicular bisector of that segment. Okay, so I know we haven't really necessarily talked about perpendicular yet, but you should hopefully remember it from middle school geometry, or the geometry you did in middle school or elementary school, really. So that just means that it's going to fall at a 90-degree angle, but we know what the bisector means because we just talked about that. So again, the steps are listed for you at the top. I'm just going to do it. So we need to put our stationary end on one point, and we need to open our compass so that it's a little bit more than halfway. So this is just an estimate. It doesn't matter like how much more than halfway, but it can't be in the middle. It can't be smaller than halfway or they won't intersect. So once you do that, move your pencil so it's above the line, and then you're going to put it down and draw an arc so it goes all the way down to the bottom. Okay, so we need those arcs to be past the midway point. I'm going to flip my paper over so I can get it on the other end point and do the same thing. Okay, so now we made those two awesome intersecting arcs. Those points where they touch, you just connect those, and this point ends up being the midpoint. Okay, so pretty awesome. I like constructing the midpoints of lines. So let's try, for example, number 8 for QT. So again, put your stationary end on a point, open your compass so it's more than halfway, start at one end and draw an arc to the other side. Okay, now switch your paper over so the other point is by your dominant hand. Same thing, draw the big arc, and then connect those intersections with your straight edge. And that is how you construct the perpendicular bisector, or the midpoint. So that would be point M, the midpoint. Awesome job, everyone. We will do more practice on this in class. Werner out.